Hello, my name is Keshwani. That's Keshwani. Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the SAT Official Study Guide 2020. If you do not own this book already, purchase one immediately. You're going to need it. Today we'll begin the very last exam in the book, the very last exam that you will find on page number 1229. Let's get going, shall we? Number 1. There are 20 multiple choice questions, which means the first one-third are going to be about easy, next one-third are medium as always, last one-third are easy, which means the first 6 or 7 are quite straightforward, quite simple. Let's get going. Number 1 says x minus 1 over 3 is equal to k. We are told that when k is equal to 3, what's the value of x? Well, let's find out, shall we? If k is equal to 3, let's put in 3 right here. When k is equal to 3, we multiply, cross multiply 3 times 3 is 9, so x minus 1 is simply 9, bring the 1 to this side and x is equal to 10. Very simple, very straightforward. Number 2. In number 2, we are given two quantities in parentheses. Number 2, we are told 7 plus 3i plus minus 8 plus 9i equals how much? Well, let's combine the like terms. We have a positive 7 and a negative 8, that's just negative 1. And then we have 3i and 9i, that's 12y. And that's all there is. That's answer choice A. Let's do the next one. Number 3. In number 3, we have two people. We are told that the first person, let's call him Michael. Michael, we are told, sends M text messages. He sends M text messages each hour. Every hour he sends M number of text messages each hour for 5 hours. Well, if you send M messages each hour for 5 hours, you're going to end up sending a total of 5 times M messages. Similarly, we are told that Patrick sends P number of text messages each hour again, but for only 4 hours. Patrick sends text messages only for 4 hours. He sends P number of text messages each hour. He's going to send 4 P messages. There you go. The total number of text messages sent by these two individuals is simply 5M plus 4P. Number 4. P, we are told, is equal to number of phones left to be fixed at the end of each day. So we have this lady whose business it is to fix phones. She fixes phones. People bring the broken phones to her and she fixes them, and over the time she has figured out that the model that she needs is this 108 minus 23 minus D. She has estimated that this equation will tell her how many phones that are left at the end of each day that she needs to fix. Question is, what's the interpretation of 108? The 108 here, which is the intercept, it simply tells us the total, this is the total number of phones that need to be fixed at the start of each week. Over time, she has estimated, which is what all the businesses do, you get some experience and you get some feeling for it, and she has figured out that on average she gets about 108 phone when she opens her shop Monday morning to be fixed. That's how she starts her week. Every week she has about 108 phone to fix. What does 23 represent? That's a slow. That tells us how many number of phones she manages to fix in one day. So at the end of one day, at the end of the first day, she still has 108 minus 23 phone to be left, to be fixed. At the end of the second day, he still has 108 minus 23 times 2 number of phones to be fixed, and so on and so forth. Question was, what does 108 represent? It represents total number of phones that she needs to fix at the beginning of each week. At the beginning of each week. And that is answer choice, whatever the answer choice is, you can find out. Number 5. Number 5. In number 5 we are told x squared minus x squared y minus 3y squared plus 5x squared, 5xy squared minus x squared y plus 3xy squared minus 3y squared. We just have to combine all the like terms and find out what the answer is. So let's do this, shall we? We just have to pay attention to the fact that we have a minus in front of it here, in front of this parenthesis. So when we open this parenthesis, all of these signs have to be changed. Negative times negative is positive. So we have positive x squared y, and I see x squared y here. So I'm going to write down this positive x squared y right underneath here. This is positive and this is positive. So that's gone. Then we have a negative times a positive, that's a negative 3xy squared. And we see xy squared here. That's a positive 5, that's a negative 3. So that one is gone. And then we have a negative times a negative. Negative times a negative is positive. Positive 3y squared. Do we see any y squared here, a term containing y squared? Or right here. And it just happens to be positive 3 and that's a negative 3. They're going to kill each other. Positive 3y squared and negative 3y squared, they're going to kill each other. There we go, we're done. All of this is gone now, we already took care of it. All of this is gone, this parenthesis can go away, and we can begin our work. X squared y and x squared y, that's just 2x squared y. That drops out, and we have positive 5 and a negative 3, that's a positive 2. Positive 2xy squared. There we go. There's no problem at all as long as you pay attention. Answer is C. Number 6. Number 6, we are told that h represents the height. We are told that it represents the height of a baby boy between the age of 2 and 5. If you want to estimate the average height of a baby boy, whatever country it happens to be, in that country, the average height of a baby boy is given by this equation, 3a plus 28.6. The question simply is, what is the interpretation of 3 in this equation? 3 is our slope. That's our intercept. What does 3 represent? 3 represents the fact that this tells us that a boy grows by about 3 inches each year. Each year, the height of an average baby boy goes up by 3 inches. And that's the interpretation of the slope. Based on the model, what is the estimated increase in the inches of a boy's height each year? The answer is 3. The average increase in height each year of a baby boy is 3. What do you suppose this represents? What do you suppose is the interpretation of this number, 28.6? That's our intercept. When a is equal to 0, this thing drops out, and we're left with 28.6. When a is equal to 0, a represents the number of years in ages. When a is 0, well, if it's 0, this represents the newborn baby. This is the height of a newborn. This represents the height of a newborn baby boy. They are not asking for that. Number 7. Number 7 looks quite intimidating, but it is not, as long as we pay attention. So we are told in number 7 that m is equal to r over 1200 times 1 plus r over 1200 raised to n, we have no choice but to write the whole thing down, over 1 plus same thing, r over 1200 raised to n, same thing as this part, except we have a minus 1 here. And then the whole thing is being multiplied by p. Whole thing we are told is multiplied by p. So if it makes it easier, we can put the parentheses like this so that it's easy to see. And I'm going to bring the m down a little bit. It should line up with this line right here, equals n. The question is, what's the value of p? What's the value of p? Well, p is simply going to be m times the denominator, m times, just like this. Let's pretend this whole thing is x. So if this entire thing is x, we have m times x plus p. If you want to solve for p, p is simply m over x. And that's all it is. But we're going to cross multiply. So we're going to have m times this denominator, and this numerator is going to come down here. Let's do it together. So that tells us that p is going to equal to m times the denominator, m times this entire denominator, which is 1 plus r over 1200 raised to n minus 1, this whole thing, that's the denominator, over this thing, r over 1200, so this comes down, times 1 plus r over 1200 times n. And that's all there is. The only difference is that, because they want to be cute, they don't want to make it too simple, only difference is that if you have some number quantity here, whether it's m times this quantity or this quantity times m, it's the same thing. Whether you have a times b or b times c, is the same thing. So what they have done in the book is that, they have, instead of putting the m here like I had done, they put the m here. It doesn't change anything. It does not change anything at all. You just have to look carefully because that m is sitting, it is sitting here. They don't even put a multiplication sign. It's just sitting here, lined up with this line here, right here, they're sitting here. So it's the same thing. The answer is B. It should have a multiplication sign to make it easier on the eyes to see it, but they don't put it there. I also would not have put it lined up with the fraction sign. I would have put it up here like I did earlier. Or better yet, just leave it here. Just leave it here. It's the same thing. It's the same thing whether it's here or here. Number 8. In number 8, we are told rather, that a over b is equal to 2. The question is, how much is 4b over a? How much is 4b over a? Let's find out, shall we? Well, first thing we notice is that 4b over a can be written as 4 times b over a. It's the same thing. We know that a over b is equal to 2. If a over b is equal to 2, that implies that b over a must be the reciprocal of it, 1 over 2. Now see how ugly this thing is no good. The equal sign has to line up, everything has to line up, like there. A over b we are told is 2, which is same as 2 over 1, which means b over a is 1 over 2. We just put it in here. 4 times 1 over 2 is just 2. 2 times 1 is just 2. Number 9. In number 9, we are given two very simple, very straightforward linear equations, and we just have to find the solution set, the point at which the two lines intersect. And here are the equations. We are told that 3x plus 4y equals negative 23, and we are told that 2y minus x is equal to minus 19. The very first thing we need to do, as I always remind you, over and over and over again repeatedly like a parrot that we must pay attention. That's all it is. It's just the time to see how well you can concentrate. Here we have 3x plus 4y, but here we have 2y minus x. X should go underneath the x, y should go underneath the y. So let's rewrite it. Let's put the negative x up here and positive 2y over there. It should have been written like this. And now we can tackle it. I see 3x here. You see, if you were to try to get rid of y, we'll have to, oh, actually we can do that also. Let's multiply the bottom equation by 2. Or, so then it will become 4, or we can multiply bottom equation by 3 and we'll have 3 and 3. Let's take the second equation and multiply it by 3. So if we multiply this equation by 3, we're multiplying this equation by 3. Multiply both sides by 3, we'll end up with, so let me erase this part now. So we're multiplying this equation by 3, both sides by 3. We'll end up with negative 3x plus 3 times 2, which is 6y, and negative 19 times 3. Negative 19 times 3. We'll worry about that in a second. Now we can write the other equation. So we have positive 3x, positive 4y equals negative 23. Let's find out what that is, shall we? Well, as you can see, negative x and a positive, negative 3x and positive 3x, they're going to drop out. They're going to kill each other, which was the whole point. There we go. So 6 plus 4 is 10y is equal to, we just have to figure out what 19 times 3 is. I have no idea what 19 times 3 is, but I do know what 20 times 3 is. I'm very bright. I do know that 20 times 3 is 60. If 23's are 60, then 19.3 must be 3 less than 60, which is 57. You see? This is how we speak. This is how we speak. 23's are 60. That's how one speaks. If 23's are 60, then it stands to reason that 19.3, one fewer 3, 19.3 must be 3 less than 60, which is 57. And they're both negative, so we just add them up. So 7 plus 3 is 0. Carry 1, 7 and 8. There you go, negative 80. Well, that's very easy. Let's put it here. Negative 80. So that's very, very easy. We're done. Divide both sides by 10, and y is equal to negative 8. Now we also have to find the value of x, which we can do up here. We're going to use this equation right here. That equation has a lot of math. We're not going to use that equation. We're just going to use this equation right here to figure out the value of x. Now in reality, I hope that you're able to see right away that we don't have to waste our time solving for x, because if you look at the answer choices, there is only one answer choice where the y coordinate is negative 8. And that one answer choice where y coordinate is negative 8 is answer choice B, which tells us 3 and negative 8. So if you want to spend a couple of seconds just to buy insurance to make sure that we did do the right work, you could put it in here, negative 8, and we should find positive 3 for x. Let's find out. Negative x plus 2y, which is 2 times negative 8, is equal to negative 19. We need the room, so I'm going to erase all of this thing. 2 times negative 8. 2 times negative 8 is negative 16. When you bring it here, when we bring negative 16 here, it's going to become positive 16, and that is equal to negative x. Negative x is equal to negative 19, and a positive 16 is going to give us negative 3, which means x is equal to positive 3. Voila. It checks out. Number 10. Number 10. Just give me 1 second. Number 10, we are given a function that looks like this. We are told that g of x is equal to ax squared plus 24. We are further told that a is constant. In other words, a is not a variable. We are told that the value of the function g is equal to 8 the value of this function g is equal to 8 when x is equal to 4. When x is equal to 4, the value of this function is 8. And this is how we read it. This is read as, not read, read. This is read as g of 4 equals 8. That's how we read it. G of 4 is equal to 8 is same as saying that the value of this function g is 8 when x is equal to 4. The question is, what's the value of the function g when x is equal to negative 4? And of course the second answer here, the second answer would be negative 8, because some people will assume that if g of 4 is 8, then g of negative 4 must be negative 8. As I said, that's the second answer. It cannot be that simple. Let's do it together, shall we? Very first thing we have to figure out is the value of a here. Let's put it here. So we know that g of 4 is equal to ax squared, which is 4 squared, plus 24, and we are told that is equal to 8. 4 squared is 16, so 16a is plus 24 is equal to 8. Bring the 24 there, which means 16a is equal to 8 minus 24, which is negative 16. 16a is equal to negative 16, which means a must equal negative 1. A must equal negative 1. Now that we have the value of a, we can find out, we can ask ourselves what's the value of this function when x is equal to negative 4, because we know now a is negative 1. We put it in here. A is equal to negative 1, and our x is equal to negative 4, so it's negative 4 squared plus 24. This is getting way too crowded. I'm going to erase most of this stuff. And I'm going to rewrite this thing so that it lines up properly. So this is our a, this part is our a, this is our x squared, ax squared plus 24. You see that? A x squared, which is our negative 4. Negative 4 squared is just positive 16. Negative 1 times positive 16 plus 24. Negative 1 times positive 16 is negative 16 plus 24, which gives us negative 8, which gives us positive 8 rather. I almost made a mistake. There you go. G of 8 is equal to positive 8. It turns out that g of 4 is equal to g of negative 4. It turns out the value of the function g is same when x is equal to 4 and x is equal to negative 4. That was number 10. We're going to stop right here. We're going to meet again tomorrow. We're going to pick up from number 11. We'll do number 11 through 15 tomorrow. And in the following video, we'll do the last 5 questions of the gradient type. Okay? In the meantime, if you wish to get hold of me, if you would like to work with me, hire me to help you get ready for the exam, you can reach me by sending me an email at my website, keshwaniprep.com. keshwaniprep.com. Send me an email over there or fill out the form and we'll talk more. Alright? Bye now.